this is where our unit technically starts. So the book, the textbook, or any materials we have do zero review. They jump right in. I decided, you know what, let's do a little bit of review because it doesn't hurt, right? It's been a while. So make sure you have your graphing calculators on you. And it's imperative that you do your homework, guys. Do a couple every day, right? Even if you can't do it all, it's very important that you do it, right? Because we have two bigger units, this one and statistics after the break. Right? So keep that in mind. When dealing with inequalities, we use less than, greater than, less than or equal to, greater than or equal to. You always read it from left to right. Okay? Think about it this way, right? The less one is on the left, right? An inequality does not only deal with the points located on the line, but also, right? Also with the points that are either above or below the line. So we're not just dealing with points on the line. It's either above or below. This is on page 17. We indicate this by shading, right? So we'll be shading the pane above or below the boundary line. Pane or area, it's the same thing. So if you're looking at inequalities, right? If you have a symbol that indicates inequalities, you know that we're no longer dealing with just the line, we're dealing with the area either above or below that line, okay? But this inequality would have a boundary line. Notice what I do between, the only difference between the left side here and the right side is the symbol. You notice that? This one has an inequality, this one has the equal sign, right? So this is just a line. We're just concerned with the line itself. This is not just with the line, but also the area above or below that line. Okay, that's important to remember. So this inequality will have a boundary line that looks like this. Okay, this is the line that's going to cut your coordinate plane into two different areas, right? So this line splitting the coordinate plane into two planes. Okay. Shading. In this unit, we'll have to shade using regular or reverse shading. Okay. So when it comes to shading, we will use regular or reverse. You will see that towards the end of the chapter, I will tend to go with reverse most often. And reverse shading is something that we as teachers introduce because it makes it easier, but the textbook doesn't use reverse shading. But you'll see why I use reverse shading a little later. But regular shading, right? When you think of regular shading, you shade the true region. Okay? When you do reverse shading, like if that's what you're asked to do, you will shade the false region. So allow me, I'm going to use a red pen here or anything you want. So let's say it doesn't matter which way the line goes, but let's make up a boundary line. So I'm going to make up a boundary line that goes down like this. So let's say we graph that line. And shortly, very shortly, we're going to know which one of these panes is the true pane. This is a true pane, Mr. Bergson. What you're making us go through, right? That's what you're thinking. But let's say the true region is above the line. So let's make a copy of this. Before we do the shading, let's copy this. It's as if we're going to have them side by side. So I'm going to take this line and kind of try to make a copy of it. And in both cases, the true region and the false region they're not going to change. It's just the way we shade that's going to differ. And shading is where, when you had to color between the lines, you're like, when am I ever going to use this again? Grade 11 applied, that's where you're going to use it again. So regular shading, we would be shading the true region, which in this case we can tell is above. So my trick is put the ruler right along the line and then just lightly, you don't have to go crazy here, okay? Just lightly shade that region. So everything above the line is going to be shaded, and because in this case we use regular shading, we shade the true region. If it's reverse shading, we're going to shade the false region. Just like that. So you notice that the true region has not changed, correct? It's above the line. It's above the line. That hasn't changed. It's just what we shade that has changed. And you're like, well, why would you want one over the other, Mrs. Rickson? Because when you graph a system means more than one, right? And you're shading this way for one line, and then another line comes across, you're shading the other way. You're supposed to determine the true region for all of them. It gets very messy and complicated to determine, wait a minute, like, where do all of them overlap, right? Whereas if you use reverse shading, if you shade out all the false regions for all of the graphs, the area that remains unshaded is going to be the true region for all of them. That's why I'm going to tend to use this. But don't worry about it too much because I will tell you what to use when, okay? And note that the textbook only uses regular shading. The true region does not change, only what we shade, okay? That's very important. Because some students think, oh, now the true region is below the line. It's like, no. It still remains, the true region is still the same. It's just what we shade, okay? Dashed versus solid lines. That's the next thing that we need to examine. Okay, so we go here. Okay. So dashed, right? If you have the inequality symbols, there are two of them, then it will result in a dashed line, right? Points on the line are not included. Right? Points on the line are not included here when it's a dashed line. If you have on the other side less than or equal to, greater than or equal to, right? When you have those, that's a solid line. And it tells you that the points on the boundary line are also included, not just the area above or below, but also the line itself. I don't know if you want to highlight those symbols. There we go. So let's make this look different, not like the one above, right? We're going to make this go up. So let's imagine you trying to graph your inequality, and then you realize, oh, I don't have the equal sign. So then we just make the line dashed like that. Okay. And it's an easy fix if you forget. If you use a pencil, you make it solid. Just go with an eraser and just erase a bunch of sections, and then you turn it into a dashed line, right? If it's greater than or equal to, then it would be a solid line. Okay. And because we're dealing with inequalities, let's make, in this case, let's make the solution or the true region. That's the one I'm going to focus on the most. Be below that. And for now, let's use regular shading. That means that we would be shading everything below in this case. And same here. So for this unit, if you don't have a short little ruler, you should probably get one. Probably a good idea. I'm just going to write down regular shading, right? regular shading used. It's a little blurry, right? And you know that ultimately this will lead to word problems, right? It's the thing about applied. Good to go? All right. So next page. Rules. There's that one rule you need to remember. Okay, don't forget this one. So on page 18, rules on working with inequalities. When multiplying or dividing, right, when multiplying or dividing by a negative, we flip, right? And maybe that's a catchy, right? We flip the symbol. What is that supposed to mean? And let's just take this one for example here. If you were to divide this by -1 and do the same thing to the other side, if you divide them both by -1, 2 divided by -1 is, you guessed it, -2. 5 divided by -1 is -5. Now there's always true or false here. This is a common theme with inequalities. Earlier, 2 was less than 5, correct? That statement was true. Which one is now the smaller one between the two? -5, right? Which means that if you kept that inequality the same way, it would be a false statement. So you have to flip the inequality the other way. So flip this way. Okay. Actually, as soon as you saw this, right? Flip inequality, right? Like you should have known as soon as you divide by a negative, anything, you know that your next statement will have that one flip the other way immediately. Same if you multiplied it, but dividing is going to be the most common one for us. Okay. So let's take this further. If you had, I'm making this one up right now. So let's say it's -3x minus 2y is greater than or equal to 10. That's another example. You would want to rewrite this. You would want to rewrite it and make it look like y is mx plus b. So you can work with it, treat this just like you would an equal sign, just like you would before. So the next line would be -2y is greater than or equal to, what happens to the 3x when it comes over? It turns positive, correct? The 10 is already there. And what are you going to have to do next to get rid of the -2 in front of the y? You're going to want to divide by -2. And so please, when you see this, you must think flip inequality. Right? As soon as you're like, oh, I need to divide by -2 here, you'll do that, you'll write it down, but then make sure the next line, it goes the other way. So it's opening, so you'd have to go this way. Right? And this leaves you with y, and this is -3 over 2x minus 5. Okay. And that's your new inequality. So I'll just do this from It went from this to this, right? That's what we did there. So it's pointing the opposite way to keep the statement true. And we base this decision on the previous example here, right? Here's we discovered, okay, we're gonna have to flip, so that we use that same notion here on this side. Now working with an inequality that has variables, right? Okay. Determining the true region or pane, test points and shortcut. So I'll give you the official textbook version, and then I'll give you the shortcut that I give my students, which is much faster. But you need to know, because you never know. Some students go and try pre-cal, and then they're like, well, they're using test points there, right? Like that's what we mean by that. So the graph of the inequality, so this inequality here is given below. Is this an example of regular or reverse shading? Okay. Regular, true is shaded. And if it's reversed, the false is shaded. That's what they're asking. Okay. How would you know? Okay. How would you know? Let's pick a test point. Pick a test point, which means pick any point on the grid. Pick any point you would like on the grid. You know which one I will suggest to you? Anybody give me a wild guess which point I will pick if I had to pick? It's the easiest one of all. What's that? That's the origin, right? This point, I will pick that one, which is 0, 0. Test point. So what you're trying to do is pick any point, and I'm picking a point in the shaded region. And let's see what happens, okay? I pick 0, 0. Question, could you pick a different one? Yes, you could pick any point you would like, but I pick 0, 0. And then we're going to substitute sub into inequality. That's your next step. So we're going to say, okay, -2, 0 plus 4 times 0, because x and y are both 0. That is supposed to be less than or equal to 16. We know that -2 times 0 is 0, right? Plus 4 times 0 is 0. 0 is less than 16. Now you pause and ask yourself, is this statement true? Is 0 indeed less than 16? And the answer is true. This is true. Right? Then you conclude, therefore, since the test point is in the shaded region and is true, what kind of shading is this then? Is it too early for this? Mr. Jackson, don't do this. 0, 0. We determined, we picked it. It's in the shaded region, correct? We picked it, we plugged it in, and it ends up being true. You know what you can conclude? That everything here is true. Anything in the shaded region, you just test this one. Hey, are you true because you're shaded, right? And the answer comes back, yep, this is actually a true region. So what kind of shading have we used here? What is shaded? The true region, correct? True region is shaded. for regular shading. This is an example of regular shading. So, Mr. Dyson, what if I had picked a point up here? What if I had picked -5, 5, this one right here? You're not going to write this down, but I will try that. So let's say your test point is -5, 5. You pick this one up here. So you plug that in. -2 times -5 plus 4 times 5 less than or equal to 16. -2 times -5 is 10. 4 times 5 is 20. This is 30, right? Is this true? No, it's false. Right? So this is how this goes. You test one point, right? I tested this point. I plugged it in and it is false. Therefore, this is my boundary line. Let's make sure we understand that. Boundary line. So that is which determines the true from the false region. Okay? This is your boundary line. If this is the true region, you don't need to check for this technically because you already know this is false. But I did check just to make sure you understand, right? Like I did end up picking this point and it did come back false, right? So that means all these points are not a solution to the system. It's only the points that are shaded, right? That happen to be below the line, okay? And so here's the trick that I'm going to show you. Actually, oops, that's what happens when I make these booklets and I actually wanted to rewrite this one. Do you think you can fit that in here? I think your writing is a bit smaller than mine, hopefully. Okay, let's try it. I'm going to section off this. I want you to see it here. So -2x plus 4y. If this doesn't fit, I promise I will have more examples down the road, and I think you'll get it then. So when you have this, we're gonna have to rewrite. That's why I asked you to practice that. So you bring the -2x over to this side. So it's 4y is less than 2x plus 16. We're gonna have to divide by 4, right? That's your Spanish number of the day. Do you need to flip the inequality? No, it's not a negative, right? So, phew, you dodged that one, right? 2 divided by 4 is half, right? Even if you don't reduce fractions, you're going to be okay. No marks will be lost. Plus 4. I just want you to see this one. So this inequality that is in standard form can be rewritten into slope-intercept form. And so can you look at this? Which way it's saying y is less than, correct? And notice that below the line, everything is true. This is below the line, right? Below, above. Like that's what we talk about, like below or above. And so now we're going to make a general rule here, so you don't need to do the test point thing. Okay, that's the point of this. I just want you to see that it is possible. So watch this. If you isolate it, right, if you have it in this form, if you see y is less than or y is less than or equal to, the true region is below. This is good study sheet entry. Not the graph necessarily, but the first 2 rows here. If you isolate like I did above, and you end up with a greater than or equal to, then the true region is above. And let's make a small graph here. I actually want 2 grids, just 2 little sketches. Let's do the same thing for so let's say you graph your line, it ends up being like this. Or you graph your line and it ends up being like this. And I will mix up dashed and solid so you don't think it always has to be. You graph your line and you notice that when you isolate that y is less than is what you end up with. So the true region is right here, true. Okay. Or you graph your line and it's going down, it has a negative slope. Your true region is below the line, right? So it doesn't matter if it's going up or down, there is a below and there is an above, okay? If you end up with a y is greater than or equal to, then the true region is above the line. I focus on the true region. You must know that if the true region is above, then the false will be below, and vice versa, okay? That's just how it goes. I will add this to the bottom of you, like these two here. If you want to make a bracket like this, these are diagonal or horizontal lines. And then we have our special case when it's just x. When it's just x, it's going to be a vertical line, guys, the boundary. So less than, right, it's going to be to the left. And x is greater than or equal to is going to be to the right. So it's not above or below. It's left or right. And there's really just one graph necessary. So this is just a sketch, okay? No need to make this fancy. So your boundary line will be a vertical line. Okay. And I will make one dashed and one solid just so you're used to the fact that it will be different. So if you isolate and you end up with that, then the true region will be right here. Sorry, true is to the left. If it's like this, then the true region is to the right. And at the bottom here, I'm going to make a bracket like this. Vertical boundary lines. Okay. So for this to work, you have to isolate. You have to write it and clean it up if you don't want to use test points. And the thing is, you're going to have to rewrite anyways to enter them into your calculator, the boundary lines. So you might as well just go ahead and do that. So I would say these two rows here, it's very good study sheet entry. If you have room for the graphs, sure, but I would say for sure this to help you remember, because students forget and then they shade the wrong area and it makes everything else be wrong, okay? and I'm focusing on the true region because that's where the solution is going to come from. We good? Okay, let's do some graphing here. Let's put this into action. Graphing inequalities, and I'm going to do the same way, the same method throughout this unit. If you have a different way, that's fine, but I will stick with one method, okay? For each of the following, determine the intercepts, rewrite the inequality, graph use regular shading. I'm telling you to use regular shading. So we're going to shade true region. Shade true, right? That's what, for now, that's what we're going to do. For now. Okay, so I'm going to find the x. You need to understand that this is an inequality. That's an inequality, which will result in shading. The boundary line, watch this, boundary. That's going to determine where I shade. It's going to be the cutoff. So notice that I take the inequality, I write it like this, and for intercepts, I'm going to use this one. Because right now I do, in fact, want to graph that line first and foremost, and then I'll worry about the shading. Let's clean that up a bit. You remember, I like this to look like that, right? I like the x and the y and then the constant on the right side. Just saves you a lot of grief. And then we'll find the x and y intercepts. And you should be really good at it by now. X-intercepts, right? 4x is equal to 10. Divide both by 4. X is equal to 2.5. We welcome decimals in this course, so don't be scared. You don't have to leave it as a fraction. It's all good. 2.50. Next is negative 5. Y is equal to 10. And then the reason is I'm letting x equal to 0, so the 4x is gone, right? So you're just left with this part here. You divide both sides by negative 5. Oh, Mr. Dirksen said something about negative dividing. Should I flip the sign? Not here. You almost forget about inequalities for a moment when you're doing your intercepts, because right now you're just worried about the line, okay? We'll deal with the inequality later. So this is y is equal to negative 2. 0, negative 2 is my y-intercept. And I want you to write it down as a point. You know why? Because students mix them up. They make the y-intercept appear on the x-axis. Or like, so just write it down as a point like that. There's less of a likelihood of you mixing it up. Because imagine having 3 lines and different intercepts. You're going to find it confusing. Okay? So we determined the intercepts. We're going to rearrange inequality. So here we deal with the inequality. You want to do this for now. So the boundary line, all of that stuff, we dealt with it here. Okay? And now we're going to rearrange the inequality itself. Rearrange the inequality. So what I'm going to do here, I hope you don't mind doing a little bit of extra writing, but right, you want to understand what's happening here. So I'm taking the inequality back from up there, and I will rearrange it. So it's negative 5y is greater than. The 4x comes over subtracting. The negative 10 also switches sides, and it goes over adding. So take your time with these ones, okay? And now what do I need to do is divide by negative 5, and that should ring a bell. Dividing by negative. So I'm going to take the inequality, and before I do anything else, I'm going to flip it. right? Flip, I don't know, it's a little small there, but it says flip there, believe it or not. Okay, flip, and then it's -4 and -5. That's just 4 over 5x. 10 divided by -5 is -2. Please make sure you check. Does this jive with the intercept I just calculated, right? If these do not match, you probably made a mistake, right? So this is good. Okay, I need that. And this is why I need that. First, I'm going to tell myself, is it a solid line or a dashed line? You remember? Previous page, it's actually a dashed line. So dashed. Soon this is just going to be a letter. I'm just going to go D dashed. Where's the true region? The true region when its y is less than is below, correct? True below. So I go arrow like that. And I'm going to shade where? I'm also going to shade below because it's regular shading. Then they match. Regular shading. Okay, regular shading is happening here. So let's go ahead and graph. 2.5 is right about there. 0, -2 is right there. And here's where you follow your instructions. It's a dashed line. So I'm not going to make it a solid line. And don't feel like you have to stay close to those 2 points. Those are just a guide. Extend it. And this inequality is, you can choose which inequality if you want to write this one down or the one you just rewrote. It doesn't matter. And so you determine that true is below. So this is the true region. I'll just say that that's true. And I'll tell you this, if you tell me where the true region is, but you're shading reverse, you still get the right, and you will still get marks. I care about you getting this right. Where's the true region? It's below. So we're going to shade that. And just shade lightly, okay? You can, so that you will have to write stuff or tell me that this is the solution region. It's all the same. Okay? This is also the solution region. It's the same thing. It's the true region, it's the solution region. Any point that I pick that is below that line, if I were to plug that into either inequality, it doesn't matter, will always be true. It will always be true. But you need to sometimes show that mathematically if that's actually the case. Is 40/30 part of the solution? Show your work. Where's 40/30? Is it even on your grid? No, I purposely picked that one. So 40 would be way down here and then 30. So it would be somewhere up here, right? If you could, way up here. So let's check for sure if it is. So we take the 4x minus 5y minus 10 is greater than 0. Okay? And you just plug these in. 4 times 40 minus 5 times 30 minus 10, and that's supposed to be greater than 0. You're like, Mr. Dirksen, why didn't you pick this one? You could. You will end up with the same answer, meaning is it true or false? But this one is maybe a little more difficult to work with, so I'm going to just stick with that. So that's 160 minus 150 minus 10. And that's supposed to be greater than 0. 160, and this is another 160, right? It ends up being 0. Is 0 greater than 0? The answer is false, right? Right? It's not greater. it's equal to, right? False. Therefore, 4030 is not a solution. Okay, not. Question. This is very important. It's such a slight difference, but it's important. Would this be true? Just an aside. Would that be true? The answer is yes. Because you need to just know what this is saying. Is 0 greater than or equal to 0? Yes, it's or. The or part is true. This is true. Okay? This is just a complete aside because it could have been the case. Could have been the case. Okay, can you do this one real quick? I'll just update my attendance. Plug this into the inequality and see if it's part of the solution. Right? Plug this point in. See if you can do just the algebra, getting your signs right, all of that stuff, and then we'll continue. See? Negative 80 minus 250 minus 10. And you can tell already that this is not going to be true, right? But we have negative 260, negative 340. False, right? Therefore, not a solution. Here we go. Could this be a test point? Yeah, but you can't see it on the graph, so it's not a really good one if you wanted to. Okay, so some more graphing. I will skip that for now. I will skip that for now. And just tell you about the special cases on page 20. Okay, so you've got your vertical and horizontal boundary lines. So if you have x and a number like this, or y and a number like this, right, you should know that your boundary line is going at negative 3 here. Right? It's going to be a dashed line, right? Let's make sure we know that. Dashed. Where's the true region? I gave you that little cheat table there. When it's greater than, the true is to the right. And we're going to shade right also because we're using regular shading here. So this is x is greater than negative 3. You know what the most important part is? Not the shading, but this. If you get this right, you're in good hands, right? So true is to the right. And think about it, x has to be greater than negative 3, right? So think about it, greater than would actually make sense that it's to the right. So I will first write down true. That's the most important part. And then I shade. So that's your vertical. That's a special case. If you see that, it's going to be a vertical line. If you see just y and a number, no x, that's going to be a horizontal line. And is this going to be solid, right? Because it has that equal sign, solid. True region is, it's less than, it's actually below. We're going to shade below. So we go and find that. It's going to be a solid line through 4. Y is less than or equal to 4. So we shade everything. Yeah, don't use a pen when you graph these things. That's not, I don't advise that because you'll make mistakes and you have to erase, right? So make sure we indicate that the true region is below. And you should recognize at this point, oh, it's true and shaded, it's regular shading, right? I would expect you to know that by now. Once we do systems, that's when you're going to see me switching over to reverse quite often. So those are your special cases, and sometimes you won't see them right away, but once you clean everything up and you bring stuff over, then you're gonna, oh, there's no X, there's no Y left, right? Whatever. Yeah. Right. Okay. So I want to have some examples where we go backwards. So let's go to page 21. This is very important. I would highlight the top because I call these backwards, right? Like you're going from the graph to actually writing the inequality. Okay. This is sort of what I've developed over the years, right? Determine the slope, determine the true region. Is the line solid or dashed, right? Then you write your inequality. So it may seem daunting, but here it is. Let's try that. Let's follow the steps. I'm going to try to keep them on there. And I usually give you a bit of a hint. So for example, between on this line, do you see that point there? You should be able to see it. It's right there and right there. So that's your hint. Use those 2 points to determine your slope. I'm going to go like this. Slope is rise over run. Okay? Is my slope going to be positive or negative? Overall. From left to right, which way am I going? I'm going up, right? So you know your slope is positive. Then I use the rise and run, right? I just go 1, 2, 3, 4. There's a 4 rise. Okay. And then I go 1, 2, 3. My run is 3. And just don't mix them up. Remember, rise, then run. Oops, sorry. Just think about it. You can't run without rising, right? So 4 over 3. So you've developed your, you know it's positive, but sometimes students for some reason develop a negative. I don't know how, but it sometimes happens. You need to know that if it's going up, it will be positive, no matter what you do, okay? And I think this is why I'm saying that, because you could technically say, hey, I'm going to drop 4 and then go backwards 3, right? So it'd be a negative 4 and a negative 3. What happens when you divide 2 negatives? Still positive. So just keep that in mind. Anyways, what's your y-intercept? This one is the easiest one of all. Let's label it on here. This is 0, 4, according to that graph, right? So from there, I'll just say, hey, I know that my y-intercept is 4. That's the B part. Then I'm going to tell myself that it's a dashed line. Okay? And where's the true region? It says solution here, which is also true, same thing. True is below the line, right? You're like, I don't know, Mr. Anderson, when I look at that, it looks to the right to me. Right? No. The only time it's left or right is if it's a vertical line. If it's diagonal or horizontal, it's either above or below. Okay? So would you say below? Yeah, okay. True region is below. So I'm kind of, you'll see that this will come together like a little puzzle here. So you start like this. Y, if true is below, right? That means I'm going to have to go like this. So check, right? If it's dash, that means I will not add the equal sign. And then the rest is like this. M X plus B. Okay. So this symbol tells you two things, right? It tells you two things, that it's dashed, and it tells you that true is below, right? That's two things right there. This is M, right? And this is B. So usually a question like this is worth 2 marks. Like it's half, 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 right? There's 4 things, so half for each component before you do that. Give this one a try, guys. Remember, don't be scared. There is 0 risk right now. Absolutely no risk. If I give you this one below here, it's basically what you want to do is this. Go through this. You want your slope, you want your intercept, you want to know if it's dashed or solid, and you want to know where the true region is. So try to figure that out. See if you can figure that out, and then put it together like a puzzle. See how you did here. So I'm not too happy with these grids, but if you need to pick your own points, be smart about it. You don't just pick and guess, right? You kind of follow the line until you see that it's crossing at an intersection. And to confirm that that's the right point, you should be able to repeat, like the rise and the run from one point to the other. You should be able to repeat that on the line. If you can't, then it's not a good one, okay? But you should see this one here and this one here. So this one is actually, oh, not a good one. Sorry. I just told you not to pick one in the middle, right? This one is actually halfway through. So I'm gonna go and see if I scan. This one seems pretty good here. So it's a right 2, 3. So I go back 3, up 2. If I do the same thing, I should be able to cut on that line, right? And you see if you do that pattern, you continue. Or if you went this way, right? 2, 3, you should be able to see the point repeats. So it doesn't matter how you want to do this, but there's a 2 vertical and 1, 2, 3 horizontal change. And this is a negative slope, right? So you can still say that my rise is 2, my run is 3, but you're going to slap a negative in front of it. Mr. Slope will help you with that, right? Remember that? Okay, so then this point right here is 0, negative 5. That's my y-intercept. So this is negative 5 here. It's a solid line. That one is easy, right? And then the true region is above. The true region is above. So from these two, you will conclude that it has to be like this, right? From those 2 points. So we go ahead and write that. Negative 2/3 x minus 5, and there it is. Let's go up here. From these two, you concluded that it was less than. Okay. Can you imagine copying this all? All these graphs, every single graph you'd have to copy. Yeah, it's quite tedious. Next page. Special cases. I always like to put arrowheads everywhere because I'm using Desmos. Desmos is not very good at that. So let's just make sure we understand, for this line, it would be a vertical, right? So it'd be X number. That's what that would be. Okay. So I will say this: it's solid. True is to the right. Okay. So from these two, you will conclude that it has to be greater than or equal to. So this would be x is greater than or equal to what? You just check right here. 2, 4, 6. No, wait. 2, 4, 6, 7. Sorry. 7, 0 is where it's going through, right? So x is greater than or equal to 7 is that line right there. This one is a horizontal line, also a special case. It would be y and a number. Okay, so we just go y, the true region, actually it's dashed, and true is below, okay, based on this. So we will say y is less than, and where does it go through? This is 5, 9, right? This is 0, -9. So y is less than -9. Okay, that is the inequality for that one. So you don't need to figure out slopes. You just need to figure out that number and the inequality symbol, right? And so make sure your study sheet has that to help you out. And I want you to try to determine both inequalities here. And then we're going to take it another one step further and determine the point of intersection between the two. The POI, I want to focus on that quite a bit. What's the POI up here? It's very easy. This point right here. It is 7, right? Because it's 7. This is the line x equal to 7 and -9. And this is what we call the point of intersection. That's going to become very important to us. Where those lines, the boundary lines meet, it's going to be important to us. So the same thing here, except for you're going to have to use your calculator. I made it so that it's not an accurate, exact intersection. So I want you to use the calculator. Use the TI-84 for this. Let's call this line A, and this would be line B, right? So to keep them different. So for that first one, we're going to figure out the slope, the intercept, if it's dashed or solid, and where the true region lies. Oh, I need to hurry a little bit. So we know that it's dashed, right? For sure. So no equal sign there. The slope, I did give a point here. So we're just going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Is it positive or negative? It's negative, right? Because it's dropping. So just count vertical, horizontal, and then worry about the sign later. How's that? Intercept is this 11? Yeah, it looks like it's 0, 11. So the intercept is 11. Where's the true region? You look at solution, it's shaded, but most importantly, where's the true region, right? It's above. Okay. So from these two, you conclude that it's going to be like this. Okay. So y is greater than -5/7x plus 11. And then we'll do b here. I gave you the points there. So this is 1. Yeah, 1. 1 and 1, 2, 3. Okay. The slope is positive. I know that because the line is going up. B is 2, 3, 4, 5, 6, 7, right? This is 0, -7. So B is -7. It's solid, right? The true region is where? Compared to this line, it's below, right? So from these two, you can conclude that it's going to be less than or equal to because of the solid part. So this is y is less than or equal to 1/3 x minus 7. So I give you a bunch of these to practice, guys. So you got to make sure you practice that. A POI, right? The A we'll put into y1, B we put into y2, and we go second trace 5. Let me just do this. So you got to be careful how you enter it. -5/7. I will give you the homework before you go, okay? X -7. So I'm graphing them both. I need to change my window a little bit. There we go. Second trace 5. Enter, enter, enter. And it's 17.18, -1.27. That is the point of intersection, okay? That is actually that point right there. So homework, I'll freeze that there. Freeze. There. Homework is going to be pages 23 to 27. Pages 23 to 27. And there's lots of graphs, which that's why there's so many pages there. But I want you to practice to graph inequalities as well as coming up with the inequality given the graph. Okay, so you need to be able to do both by tomorrow because I will AC you on that. Okay. Thank you guys.